All right, folks. Can somebody remind me? We talked about that empirical rule last week. What did that empirical rule really mean?
I thought we did probably.
We kind of did the last page and then we came back to this.
Oh, it's the 68, 95, 99.7.
Yep. All right, so I'm going to draw a normal curve. Right? And we said if I go one standard deviation on each side of my mean. So are you guys cool if I call this a positive one and this is a negative one, so it's one above the mean and one below the mean? Is that okay? And if I did that, what was that percentage on the inside? 68%. And then if I went two standard deviations above and below, that total was 95%, making each of these sections 13.5% and 13.5%. Is everybody good with what I'm drawing here? Clean this up a little bit. And then we went three standard deviations on each side, and we had a total of, so it was 68, 95, 99.7, so just about everything, right? So this would be 2.35%, 2.35%, and then those itty bitty tails are 0.15% and 0.15%. Is this all familiar?
Yes.
Okay. And so it was really great. Like, let's say I gave you a distribution, we'll use IQ, that has a mean of 100 and a standard deviation of 15. And I said, what percent is between 70 and 115? Well, this is minus 2 standard deviations. This is plus 1 standard deviation. So if I said what's in between these two ranges, we could find that pretty easily by adding up all those percentages, right? But now, what if instead I said, well, what percent is between 80 and 105? All of a sudden, that becomes a much more challenging percentage to find. Does that make sense? Because that 68, 95, that was only whole number of standard deviations away. Well, what we use is a special distribution called the standard normal curve. Standard normal. And the picture of the standard normal curve is a normal distribution with a mean of 0 and a standard deviation of 1. And it turns out, remember how we calculated those z-scores? Hey guys, the z-scores were how many standard deviations above or below the mean, yeah? This is a graph of all z-scores, okay? So, if I asked you what percent on this graph is between -1 and +1, could we answer that question? What is this percentage?
68%.
It's 68%, because that's exactly 1 standard deviation above and below the mean. All right. Now, when we do the stuff we're about to do in our calculator, what we're going to find is the area in between different values on this curve, and that area is equivalent to the percentage. So, at this point, take out your graphing calculators. And one of the reasons we care about the normal distribution is that it is everywhere. You know what? I'm going to do this the other way. Hey guys, does anybody want to guess the likelihood I dropped this calculator in the middle of class, like onto the floor?
40%.
60%.
No, the center of the weight is over the counter, so I think it's good.
I mean, it is
No,
right now, but I don't
saying,
sit still
like, she
very well.
might knock it or like.
Yeah, it's fine. Well, it's like the screen is like not the part you're touching.
Well, there's also something that's creeping me out is that my foot is in the shot, which feels a little bit weird as well.
I didn't even notice that. Good for you.
Did you notice that?
You know, honestly,
Is
I
it-
don't know about myself.
What are we thinking? Does that look good? Can you guys see that?
Yeah.
All right.
You can see a tiny bit of the table.
I'm okay with the table. I'm not okay with my foot. Like that just feels a little bit weirder. Okay. So what we like about the normal distribution is not just that tons of things are normally distributed. It's extremely predictable. It's one of many, many extremely predictable distributions. And what's great about that is anything that's extremely predictable can be programmed into a piece of technology such as this. This. Cool? Now, what I'm about to tell you is going to sound like I'm talking to you like you're a 5-year-old. I don't mean to treat you like a kid. Instead, what I'm trying to do is teach you guys how the calculator was built. Okay, because it was actually built with a logic process behind it. And heaven forbid you are trying to do some of this outside of school, you should be able to, do it. So, I would like you guys to stare at your calculator and see if you can't find something that would help you with known predictable distributions.
Program?
Maybe. Anybody see anything else that might work better?
Second bars.
Do you guys see how it says distra
Yes.
above the vars button? Okay? So go ahead and hit second vars. And when you do that, you see all these options. Does anybody see anything that might help us with the normal distribution?
The
Normal?
We've got 3 different things that say normal next to them, right?
I'm saying PDF.
How is normal?
How is normal 3 different things? Because I said so. Duh.
I'm going to say number 1.
We're going to use 2 of these 3 things. The only one we're not going to use is number 1. Yeah, I gotcha. It's silly, but we're not. Okay? So what I'd like you guys to do is pick option number 2 where it says normal CDF. And the minute you do, your calculator should be asking you for a lower and upper, and then it has some weird symbols. Is everybody with me?
Yes.
Okay. Your lower and upper are describing where you've shaded on your picture. Okay? So when you look at this graph, what is my lower boundary of what is being shaded?
Negative
199.
So you're, no, on the picture.
Oh,
The lower boundary is
negative.
-1. What is the upper boundary of what's being shaded? 1. Now, that curly QM, that's supposed to be the mean, which on our picture turns out to be 0. And then that other one is that symbol for the standard deviation that we kind of use sometimes. So we're going to leave those as 0 and 1. Now, Thea already told us what the answer is going to be. What do you guys, the answer is going to be approximately 68% because of that empirical rule. If I hit enter, do I get approximately 68%?
Yeah.
Wait, what? I'm getting 1.
I'm getting error.
I got negative 1.
Well, then hit enter.
Ah, yes.
Someone said you got an error?
That was me.
Well, what'd you do wrong?
Negative 1, 1, 0, 1, and then you just hit enter on pace.
Mm-hmm.
I'm getting X.
And then hit enter one more time. What? I can't read that. What does the message say?
Check all arguments entered.
Oof. For the negative one, did you hit the minus sign or the negative sign?
The minus sign.
Use the negative sign. And that'll fix it for you.
Thank you.
No problem. That's a common mistake. Otherwise, how would I have known that? Right? Very common mistake. Griffin, were you able to get it?
Yeah, I don't know what I was doing wrong.
Did you use the negative sign or the minus sign?
No, I used the minus sign.
You're supposed to use the negative sign.
Or, yeah, I did use that one.
But you got it the second time around?
Yeah, I typed in everything the same. I think the calculator is wrong.
Sure.
Yeah, that's probably it. Yeah. Okay.
Which one is the negative?
The one next to the period sign.
Ah, yes.
Okay. Let's look.
It looks like hyphen.
All right. Thank God it was recording. All right. So now, I don't know why I did this twice. So if I ask you what percent of values are between -1 and 1, we just kind of did this, so I'm just going to kind of write this up while you guys are turning your pages anyway. That answer is 0.68. Now, what if I asked you what percent is to the right of 1? Could we figure it out using the empirical rule?
I think we could.
Yes.
I think we could too. It'd be about 16%. Probably to the right of +1 would be 16%. You don't believe me?
No, if the whole thing is 68, wouldn't it be 34%?
Well, so this would be,
Oh, I thought.
and this would be, these two combined would be 32%,
I thought
but
you
this
meant-
one would be
I
0.16. So
thought you meant if you split the 68.
no, when I said to the right of 1, what I meant was at the 1.
Thanks.
No problem. All right. Now, hey guys, what about to the right of 1.7? So now we don't have a whole number of standard deviations above or below my mean. Now, if this were strictly a 1, it'd be 16%. If it were a 2, it would be 2.5%. Are you guys with me from that empirical rule that that's how it would play? So we know it's somewhere between 2.5% and 16%, but we don't know the exact value. Is this okay? So we're going to go back to that second distribution menu. Oh, you guys can't see this because I stopped it. Hold on. So we're going to go back to that second vars. We're still going to choose normal CDF, option number 2. But now, what's my lower boundary of what's being shaded?
1.7.
Okay. So for the lower, we're going to put 1.7. For the upper, what do we put?
Two?
It's got to be more than 2.
3.
And I don't know how to put in infinity.
Just type in a lot of numbers.
That's exactly what you do. You type in some really big number. That's it. As long as you're close to infinity, you're fine. You hit enter.
For real?
Yeah, I thought you were being sarcastic.
No. You just put in a really big number.
Do we not change the standard deviation?
Not yet. Well, our standard deviation is still 1, yeah?
Okay, I was unsure.
I just did one and a
It's not
bunch.
object.
Yeah. You just do 1 in a gajillion. Put in a gajillion. And I in fact get 0.0445. And does that make sense? We said it was somewhere between 2.5% and 16%, right? And it's going to be closer to that 2.5%. Is this working out okay?
Yes, Miss Meister.
All right, so what if I asked you less than 1.2 standard deviations below the mean? We draw that picture. .2 would be about here-ish, right? Less than would have me shading to the left. All right, so I go to my calculator. I go second vars and bring up the normal CDF again. Now what's my lower boundary?
Infinity.
It is not infinity. It is
Negative 1.2.
not negative 1.2.
Negative.
How about negative infinity?
Whoa!
Because it's like down here,
You'll be a valid point right there.
right? This is my lower boundary. So I go negative a gajillion. What's my upper boundary?
1.2.
1.2. Everything else stays the same. We hit paste. We get our answer as 0.88% or 0.885. I'll call it 0.885. Hey guys, does that look roughly 88.5%? Does that feel right?
Yeah.
Roughly. Actually, no. It's the red part, right?
Well, it's the all red part.
Oh, yes, I would say.
This I was just trying to highlight the negative infinity part of it. All right, and then why don't you guys try this last one? Between negative 0.43 and positive 1.3. It's also easier for me than it is for you guys, because the Apple Pencil is a lot smoother on the glass.
Sometimes it corrects
It
it.
gets a little more
Well, the more you do, the easier it gets. But I'm still horrible at it, so I don't know what to tell you.
Well, you'll have plenty of opportunities to draw them.
Great. It's really exciting.
I just like bust into Mr. Richards' room and be like, "Who's screaming in here?"
No.
Oh.
What are we getting?
0.5696.
0.5696.
0.57.
0.570.
It's not even letting me get to the city yet.
Second verse.
Yeah, second, bars, 2.
What's it say? I can see it up at the top. What's it say? Inside the.
PDF.
Okay. Okay, so here's what happens. You need to be like, if I choose normal PDF accidentally, right? Notice that the first thing it says is X value. So when I try to go to normal CDF after that, it starts trying to fill in this normal CDF into that PDF. So you just have to be quit, and you want to be in like this main calculator screen. You guys, so we got 0.57? How we feeling? Everybody okay? All right.
But he said because he has to go to the term, that I had to start playing with
It's crazy. There's a emoji.
All right. Hey guys, if I asked you, if I gave you this picture, and I don't know this. This is my question mark. Okay? But I tell you that this is 16%.
Okay.
What's that cutoff for the lowest 16%?
The first two sectors.
I'm sorry?
The first two sectors.
The two, okay. So are you guys with me that Z-score is exactly one standard deviation below the mean?
That seems right.
Because let's see. This would be 34%, right?
Yes.
And combined, that should be half of it to the left of the mean. So 50%, okay? So just like your calculator can find the area, it can also say, like, hey, if I know the area, I can find the Z-score. So, how many standard deviations away from the mean is the lowest 10%? Let's draw a picture of that. Where's the lowest 10%? Tell me when to stop.
Stop.
You guys feel good with that being about 10%?
Sure.
Now, this number is not 10. It's not 0.10 because it's to the left of 0, so it's negative in some way, right? What we know is this area is 10%. So what we need to do, like before what we had was we had this cutoff value. Gotta get my foot out of the picture. So weird. we knew the cutoff value, we knew the boundaries of the shading, and we had to find the area. Now we're going backwards. We have the area, we don't know the boundary, and we're trying to find that boundary. So we need our calculator to work backwards. Does anybody know the math word for backwards?
Reverse.
In particular, when you look at these three options, does one of them seem to be the math operation for backwards?
Inverse norm.
So you're going to choose number 3, inverse norm. Notice that when you choose number 3, inverse norm, it asks you, wait, what's the area? What is our area?
10%.
10%. Now, if you put in 10, you're going to get an error. You can't put in anything larger than 1. So 10% is 0.1. That's what you have to tell it. And go all the way down, and I get negative 1.28. Does it make sense to you guys for this number right here to be negative 1.28? Does that feel right?
Yeah.
Yes.
Why? I am so irritated with this new program. Okay. All right, now, how many standard deviations away is the highest 20%? Well, where's the highest 20%?
2.
Two?
84. Negative 0.84.
Can you guys help me color my picture first and foremost? Where would I color for the highest 20%? To the right? So I'm going to start on the right and work my way down, yeah? Tell me when I'm at approximately 20%. Okay? And I know that this area is 0.20, yeah?
Yes.
All right, now, those of you going to put this in your calculator, before we talk about this more, I want you to think about something for a second. Can your calculator see which direction you've shaded this?
No. That's not obvious.
So as we think through what are we going to tell our calculator, you can't just put in the same thing. Your calculator thinks, or is defaulted to anyway, the left side area. Is everybody with me? So if this is 20%, this area is 20%. What does that make this area?
80%.
80%. Is everybody good with that idea? So what are you going to tell your calculator? You're going to tell your calculator the 0.8, not the 0.2.
No, it sounded like a monkey. Sorry to distract.
Are you?
I am, because that was also on recording.
But if you just, it gives you the same answer if you just tell it somewhere.
Not all the calculators do that.
You just have it.
Wait.
So do you.
The older black and white ones don't do that. So, oh, I should probably put it in still. So I go to put this one in, and I'm going to put in the 0.8. Now, if you plugged in the 0.2, and you got negative 0.84 instead of positive 0.84, I want you guys to look. If I write that negative 0.84 right here, is it bothering you guys to see that negative 0.84 to the right of 0? Does that make sense? Okay, so there's ways you can check yourself to not make that mistake, is to make sure your answer actually makes sense with your picture.
We did it so we put in the 0.2, but we made the thing instead of left to say right.
Yeah, that's fine.
Okay.
But not all the calculators have that.
Yeah. Isn't it right?
It is.
So
So
what?
there's reasons why I don't do that. Don't teach you guys to do that. For one, it's not because not all the calculators do that. It's also because there will be times this year where you have to use a different but similar feature of the calculator that doesn't have the left, center, right for you. So So understanding that your calculator thinks in left side area is important.
So can't we just switch it to right?
But she just said that.
I mean, I feel like
I'm
saying the
not
same.
following.
They're going to be.
It's okay, it's okay.
There's going to be something you have to do later where that left, center, right won't be an option. That
Yeah.
you'll still need to understand the left,
Oh, okay. I
the
got
left hand, like the two sides adding up to one.
you. I got you.
I'm trying to build groundwork here. All right. Yes.
So if we're trying to answer for that right part, that very right part, that 20%, why do we have an answer of 0.8?
So your calculator can't see which side you're shading, right?
Yeah, but
So in your calculator's head, you give it the left side area, and it tells you the mark for that left side area. So the fact that the question asks for the right,
I just realized I thought wrong. I was still thinking that 0.84 was that 20%. I don't know why. Don't ask me why, because I don't know.
well, so when you put in the 20, you got negative 0.84, which would just be its symmetrical point on the other side. All right. Can you guys tell me the middle 90%? So let's draw a picture of what that looks like. So this is 90% in the middle. What does that make each of the tails? So, because now we have kind of two pieces, right? 5%. So this one is, are you guys cool if I call this 0.05 and this 0.05?
Yes.
Okay.
Yeah.
Now, what do we know about this value? It's going to be negative. This one is going to be
Positive.
positive. Are you guys comfortable saying that they'll be the same number? Just one positive and one negative?
That makes sense.
Is this okay? And I bet I can guess it. I bet it's 1.645.
Why?
The z-scores you get when you plug in.
Show your math.
I have them memorized for 90, 95, 99. I think I could do 80. I think 80 would be 1.28, I think. There's certain ones because I use them over and over and over again. Like this is doing the math, putting it in the calculator from here. But I'm pretty sure you get 1.645. There's stuff we'll be doing in like January.
How many decimal places do you want us to have?
I don't know, 2 or 3 seems reasonable.
Do you put it in the calculator like as 0.9?
No,
No.
because your calculator only thinks left side, right? So if you're going to put in this, like, if you want to find this one, what's the areas to the left of that value? It's 0.05.
Yeah. So you do 0.45?
No, just 0.05.
Oh.
And that'll get you the negative 1.645.
And then do you just,
And when it's this one that's centered at 0,
yeah,
you'll also get, the other one's going to be plus or minus of the same number. If they're not centered at 0, like, it's a little messy.
so if they are the same number, then if you add them together,
You'd get 0.
0.
Yeah. For the middle chunk, yes, but it's not necessarily always going to be that. So, Griffin, to answer your question of what do you plug in to find this one, you would do 0.95,
Okay.
because when you think of like what is this total area, well, it's the 90% in the middle and the 5% on the tail would be 0.95, and that would get you the positive 1.645.
Okay.
On a scale of 1 to 5, where are we? You can just do a little hand signal. Okay. I'm done.